I think it started today, and I'm going to start from the very beginning of class 12, and I will give you brief about the chapter which you have studied. Then I will start from the competitive section and beyond that. So before that, let me introduce myself. I am Atik Hassan, and I am taking class from Delhi, and I am BTech as well as MTech. I have more than 10 years of teaching experience, and I was also an aspirant of IIT JEE. I was selected also. I did my BTech as well as MTech, and most of the experience in teaching is from JEE as well as NEET since last 10 years, more than 10 years in fact. Apart from that, I also have writing experience. I am author of more than 7 books, uh, as well as some of the I have idea of content development, question paper making, how contents are created in competitive exams, and that. So that kind of experience will also be helpful for you guys. So okay, uh, let us start with the very first chapter, that is electric charges and field. All right. So first of all, I will answer your voice is not that good. Shravya, can you hear now? Can you hear me now?
Yes, sir.
Yeah, little bit there is fluctuation of internet today. It will be sorted out soon. So if we see class 12 section, like and let me on the video. Can my video is off, right?
Yes, sir.
Can all of you can see me? Okay.
Yes, sir.
We will start with class 12. What are the contents of class 12 and what are the sections which we are going to cover in the whole 12 syllabus? So if we see class 12 physics, it is mainly the part covers are like you can see electrostatic. First is electrostatics. Then we have in electrostatic section, we are mainly going to deal with 2 chapters. First will be electric charges, and field. Second will be electrostatic. Second will be electrostatic potential and capacitance. So mostly in electrostatic section, we will be dealing with the charges at rest, right? In electrostatic section, you will have 2 chapters. One will be electric charges and field, and another will be electrostatic potential and capacitance. So in the section of uh, 1 second, so in the section of electric charges and field, you will be dealing with like Coulomb's law, electric field, after Coulomb's law, will be dealing with the forces. Apart from that, you will go to the section of electric field due to point charges, electric field due to continuous charges. Then we will come to a section of electric dipoles. So these all will be covered in electric charges and field. After that, we will have the second chapter, electrostatic potential and capacitance. In that section, you will be dealing with electrostatic potential. Uh, then we will see the electrostatic potential energy due to different configuration, right? So uh, in the second chapter, mostly we are after that section, electric charges and potential energy, we will go to capacitors. Uh, in that section, we are going to deal with combination of capacitors, series and parallel combination, the charge is stored in the capacitors. Apart from that, we will see different type of configuration which are important from computation point of view. We will have different questions. So let me brief you first. My whiteboard is not working. Yes. Sorry for inconvenience, but that whiteboard started, hang, so I cannot write anything further that. So in the first chapter, that is electric charges, electrostatics. The first section, electrostatics. Can you all see my screen now? Electrostatics.
No, sir.
The first chapter we will deal with electric charges and fields, electric charges. And the second chapter will be electrostatic potential.
So you're not sharing your screen.
Uh, Are you able to see my screen?
No, sir.
No, sir.
Oh, once.
Now it's visible, sir.
Oh. Can you see the screen now?
Yes,
Yes,
sir.
sir.
Okay. So this is electrostatic potential that will be resolved by next class because today I am doing class from different internet connection. My Wi-Fi is not working, so this issue is coming. So electrostatic potential and capacity. All right. So these are two main sections in the electrostatic section. Now coming to the electric charges and field, the very first chapter, electric charges and field. This first chapter is very important from JEE So all of your JEE aspirants, how many of your JEE aspirants and how many of your NEET aspirants? Can you raise your hands? Or JEE? So Shravya is JEE. Okay. My Mona is for NEET, Shravya is JEE. Okay. Okay, both. So both type of students are there, NEET as well as JEE. So my planning of the lecture or my pattern of teaching will be, I will start from NEET section and move out to the JEE section, and each and every chapter we will do both questions. We will do NEET as well as JEE question. So NEET students will get benefit out of it from both the question because they are practicing NEET questions also, and if they are practicing JEE question, that is also not harmful. And if we talk about JEE students, they are also getting benefit of both because in JEE main section, uh, questions are up to the NEET level, so that question will be beneficial for them also. So there is no issue if we have both type of students. I will teach up to the JEE level from NEET section to JEE section, and that will be beneficial for both these. So if we talk about electric charges and fields, and if we talk from the JEE point of view, the, all of you heard have learned in this chapter electric charges and field the properties of electric charges, right? The properties of electric charges. The properties of electric charges. So in this section we have studied different type of properties like uh, summation of charges, quantization of charges, conservation of charges, right? So if we talk from JEE perspective, the one topic that is quantization of charge, that is very useful. If we see the property, I am not going to dictate each and every property, but if we talk about quantization of charge, that becomes little bit important from NEET perspective as well as from JEE perspective, from JEE main perspective up to some extent. So if we talk about quantization property, all of us know that the charge is integral multiple of, if we see, elementary charge. That we all know, right? That everyone
Yes,
know.
sir.
The quantization of charge says that charge on any body is integral multiple of elementary charge, where the value of n can be 1, 2, 3 integer, right? Now, based on this, and apart from that, we all are aware of Coulomb's law also. So I will use this quantization of charge and Coulomb's law also. So based on the quantization of charge, I would like to give you one question, very first question of the lecture, and I want to all of you to solve this question that is based on quantization of charge. That is very easy question or conceptual question. So the question is charge charge of 8 into 10 to the power minus 16 coulomb is charge of 8 into 10 to the power minus 16 coulomb possible is charge charge of 10 to the power minus 16 coulomb. Yeah, or you can frame the question as is charge on a body. You can write like this: is charge on a body of 8 into 10 to the minus 16 coulomb possible. Your answer should be in terms of yes or no. Is charge of 8 into 10 to the minus 16 coulomb on a body is possible or not? You have to answer it in the term yes or no. All of you. This is based on quantization. So Samira is saying no, Shravya is saying no. Krishna is also saying no. Because it is not integer, it is fraction. Okay. So I got answer from 1, 2, 3, 4 first. No, my name is also so most of you are saying no. Okay, so let me check. Is this possible or not? So how why you are saying this is not possible? You are saying that this is not an integer. Some of you told me that this sir, I think yes, because I'm looking to into 10 for 10 is to 3. So we are saying I recalculate. Okay, let us go to the answer. Let me check is this charge possible or not. So what we will apply, going to the solution section, what we will do here first, we will see the concept which is applied. What is concept should be applied here? The concept is charge should be integral multiple of elementary charge. And we will put the value of Q, the given charge. If it n comes as integer, then the charge is possible. If n doesn't come as integer, then this charge is not possible. So let us see. The value of given charge is 1 in the question. It is given as 8 into 10 power minus 16 coulomb, right? 8 into 10 to the power minus 16, and we have to calculate in, and value of E we all know 1.6 into 10 to the power minus 19. Okay, so what is the value of N? It is 8 into 10 to the power minus 16 divided by 1.6 into 10 to the power minus 90. So what is the value of n we are getting? We will get the value of n as 550 into 10 to the power 3. So it will come at 50,000. Is it integer or non-integer?
It's an integer.
Oh, obviously it is integer. So this charge is possible. So our
Yes,
answer should be
that
yes.
answer.
Okay. So it seems like it's not integer, it's fraction kind of thing, but we have to calculate it by applying formula and we will get the right. Okay, so our answer is this. All right. Based on this property, I will have one more question. Then I will move to some previous year question. So let us come to second question. Suppose so all of you understood the first question.
Yes, sir.
Yes, sir.
Any, okay, anyone having doubt can raise the query and can directly can instantly ask. No hesitation. Okay. So I assume that all of you understand the first question. Now moving to the second question. Suppose we have future. Question has also been asked in the examination. It's an old question, but asked in the examination. So we have two charges, Q1 and Q2, and this is based on quantization of charge. Very basic question, but very conceptual question. And till now, I have a history that in any class I have given this question, no one has solved till now. It's a very easy question, but no one has given me the right answer till now. In the last class on Tuesday, I also have put this question in the class. No one has given me the answer. In my coaching institute, I also gave this question. No one has answered, although it is a very basic question. So again, I'm trying, and I hope you guys can give me the answer. So I have two charges, Q1 and Q2, 2 point charges separated by distance. It seems to be very basic question, but it's not that easy. And you have to find maximum force. Maximum force. If maximum, oh sorry, minimum force, not maximum. We have to find minimum force. We have to find minimum between two. So all of you can write also. It's better and write the question. You write. We have two charges, Q1 and Q2. We have two charges, 2 point charges. We have 2 point charges, Q1 and Q2. We have 2 point charges, Q1 and Q2, separated by a distance d. We have 2 point charges, Q1 and Q2, separated by a distance d. So find the minimum force. Find the minimum force. Find the minimum force acting between Q1 and Q2. Find the minimum force acting between Q1 and Q2. So solve it. All of you try. All of you are trying?
Yes, sir.
Yes, sir.
Okay. I got one answer, A given Q2 upon B square. I got second answer 9 into 10 to the power 9. I got one more answer 23.04 into 10 to the power minus 29. Anyone else? The record is going to be maintained this time also. Next answer I got 23.04 into 10 to the power minus Krishna's 26. Krishna answer seems to be maybe correct. Let me check. Let me check. Okay, let us see. I also have to solve the question and get the numerical value. Krishna's answer seems to be close to the answer. So let me check. So let us see. We have to use the property of quantization of charge. So the charges are separated by distance d. So first concept, what is concept? Here we will apply two concepts. Concept one, that Coulomb's law will be applied. Coulomb's law, and concept two, which is quantization of quantization. Okay, so So now we have charges separated by distance d. So when we will apply Coulomb's law, the force will be F, which is given by K Q1 Q2 by d square. Right. Now what we have to do, we have to find the minimum force. We have to find the minimum force. So for that, if to be minimum, we know K is also a constant and D square is also a constant. So the product of Q1 and Q2 should be minimum. The product of Q1 and Q2 should be minimum. So what is the value of Q1, minimum value of Q1 and Q2? We know that Q1 can be written as N1 into from quantization property of charge. We know that every charge is an integral multiple of elementary charge, and Q2 can be written as N2 into E. To find the minimum value, the value of N1 should be 1 and the value of N2 should also be 1. So minimum value of Q1 Q2 should be equal to E square, right? The minimum value of Q1 and Q2 should be E square. In hurry, what we do, we take value of Q1 and Q2 as 1 coulomb, which is not correct. We have to take Q1 and Q2 minimum value as elementary charge. We cannot have charge less than, so minimum value of charge should be E, not 1, 2. Here we do mistakes. So now it is easy to calculate F minimum. So F minimum will be K by D square into D square. Right or wrong? How many of you got this? K by D square into D square? I think Krishna got this one.
Sir, even I got.
Yes.
Okay. So who was saying Mamuna? My Muna is also got that. Or which one? Okay. So let me calculate further. We have if minimum is equal to K by D square E square, then we will get, like, we will put the values, correct? For F minimum, we will put the values. So K by D square. So what is the value of K? K is 1 by 4 pi epsilon naught, that is 9 into 10 to the power 9. We can write it like this. And D square. And what is the value of elementary charge? 1.6 into 10 to the power minus square. So in this way, we will get 9 into 10 to the power 9 divided by D square. And we will calculate this. This will come as 2.56, and this will come as 10 to the power minus 13. So it will come as 22.04 divided by D square into 10 to the power, how much it is? 10 to the power minus 29, right? So the answer will be 22.04 into 10 to the power minus 29 divided by d square.
Sir, I think it
So
should be
you both
23.04, right?
got almost
Yes, sir. It
23.
is
Have you
23.
let me use calculator. I have calculated by myself. So 2.56. Let me check.
So can you explain again for this concept?
Okay, sure, I will. Let me check first calculation, then I will explain it again. 2.56 into 9. Yes, 23.02. Correct. So both of you got the correct answer, and I am very happy that in this is the first class where I got the correct answer. 23.04 upon d square. So clap. I will at least I will give clap for both of you. Mamuna and Krishna. Mamuna has missed the point d square. You must give divided by d square also, right?
Okay, sir.
So almost you both were near to the answer. So now who is asking? It's
Sir, Mehraj.
okay. So which term you want to explain me again, or so where you are facing
So the
difficulty?
sir, the whole
Whole
concept, sir. Sir, after
whole concept.
after we use Coulomb's law, that is K Q1 by Q2 by D square, and sir, after that, what will be?
Okay. So you understand this part, right? F is equal to K Q1 Q2 by D.
Yes, sir.
Right. So the question asks that we have to find minimum value of this. We have to find the minimum value of this force. The force acting between Q1 and Q2 is K Q1 Q2 by D square. This expression comes from Coulomb's law, which we all know. Now the twist is that we have to find minimum force, if minimum, not just the force. So for that purpose, what we did, if this force is minimum, we know that K by D square is constant. This we all know, correct? K by D square is constant because
Yes.
the value of K is 9 into 10 to the power 9. D is given in the question. So K by D square is constant. Now, for force to be minimum, the product Q1 and Q2 should be minimum. Got it or not? For
Yes, sir.
force to be minimum, the product Q1 is to Q2 should be minimum. I'm very sorry for that. My writing is not going good in this code. But if you face any issue, please tell me anytime. Okay, I know my writing is not going good in this code. You know, we have a habit of writing on the black boards or boards with the markers. So we are facing some issue in writing on board. But if you see facing any issue, sometime you please tell me, sir, your writing is not visible or I'm not able to understand. Alright, all of you. So F minimum is K by D square Q1, Q2 should be minimum. So for that purpose, we know that Q1, and now we will apply the concept of quantization of charge. What quantization of charge says? Quantization of charge says that the concept of quantization of charge says that Q charge on any object, charge on any object is integral multiple of elementary charge E. Charge on any object is integral multiple of elementary charge E. This is the property of quantization of charge says any body cannot have charge beyond integral, the charge must be like E, 2E, 3. That we all know, right? You understand quantization of charge?
Yes, sir.
Okay. So from this property, we have put the value of Q1 as N1 into E and Q2 as N2 into E. The value of Q1 as N1 into E and the value of Q2 as N2 into E. This point you got now?
Yes, sir.
Now we have to find the product Q1 into Q2 as minimum. We have to find minimum value of Q1. So for that, N1 should be minimum, which is 1. The value of minimum value of N1 is 1. The minimum value of an integer can be 1. We cannot give 0 because if we will give 0, then there is no question of charge. The force will be 0. Say apart from 0, the minimum value of an integer is 1. So value of N1 is 1 and value of N2 is also 1. So in that case, Q1 minimum value of Q1 Q2 comes as yes. So this was the whole. After that, we are much clear. We have to just put the value of Q2 as E square. We have to put the value of Q1 Q2 as E square. Because here we got the force like this. So we put the value of Q1 Q2 and the value of Q1 Q2 is E square. Value E square. Now we got the minimum value. Then we put the value of E. The value of elementary charge is 1.6 into 10 to minus 90 and it's a square. Then we calculated this. Now everyone I think understood the question. Is there any
Yes, sir.
doubt? Still any doubt? Okay. So are your query resolved?
Yes.
We are asking. Okay. So this is the minimum value of force between two charges. In sometimes in the question, they may give the value of D, the separation. So in that case, we will put the value of D. Here, the question in the question, the separation itself is given as D. Sometimes they may give 1 centimeter, 2 centimeter, 10 centimeter. Then we will put that. Okay. So this question was based on Newton's Coulomb's law. Sorry, not Newton's, Coulomb's law. Now moving to the next question, which is asked in JEE, the third question, which is also based on Coulomb's law. So let me give you the question. All of you can write the question. It will be better. So let us write question. This question which I am giving you has been asked in NEET 2019. So let us write the question. 2-point charges. 2-point charges. 2-point charges. A 2-point charges A and B. 2-point charges A and B. 2-point charges A and B having charges plus Q and minus Q. 2-point charges A and B having charges plus Q and minus Q. All of you writing the question?
Yes, sir.
Yes, sir.
2-point charges A and B having charges plus Q and minus Q respectively are placed at certain distance apart. Are placed at certain distance apart, and force acting and force acting between them is F, and the force acting between them is F. Full stop. If 25% charge of A, if 25% charge of A is transferred to B, if 25% of charge, if 25% charge of A, 25% charge of A is transferred to B, comma, then force between the charges becomes, then force between the charges becomes. Your options are F. The second option is 9F upon 16. The third option is 16F upon 90. And next option is 4F upon 3. So this question has been asked in NEET 2000. So solve it. All of you understood the question?
Yes.
Okay. So Maimuna got answer as option B, 9F by 16, and Shravya also got the answer as B, 9F by 16. You both are correct. 9F by 16 is the correct answer. Anyone else? 9F by 16 is the correct answer. It has been asked in 2019 recently. Anyone else who has got the answer? Should I solve it or you are trying? So, generally what happens if I give a question, what I expect is that every one of you is trying. Let me give you an example. Like suppose, you know, you want to learn to drive a bicycle. Okay, you learn to drive a bicycle, and what I do, I write on a plane of paper and give it to all of you that bicycle will be driving like this. You go uh, when a vehicle comes, you turn right, you turn left, or this and that, and you don't practice on the road or on the ground. You just take the sheet of paper and start driving. Will you be able to drive the cycle? Obviously no. So something has to be practiced. So in the same way, while learning physics, you have to practice the question. That is very important. Either you got the answer or not, that is different thing. But if you will try the question, even though you don't getting the answer or getting the answer, if you're getting the answer, well and good. If you're not getting the answer, then that is also useful for us, because we at least we will know that where we were wrong, where the concept was wrong, what was the mistake. So that thing we will able to identify. So always try a question. Either you are getting answer or not. So that's why I'm giving you the time after every question. I will give you some time so that you can solve this. So let us solve this question. What it says that 2 point charges A and B. What it says that 2 point charges A and B. There are two charges. 2 point charges are there. One charge is A and another charge is B. And they are plus Q and minus. The question says the charge A and B are plus Q and minus Q respectively. And suppose they are placed at a certain distance d. In the question, the distance is not known. So we will assume that these charges A and B are separated by a distance d. Now what the question says, are placed at certain distance apart and force acting them is F. So in this situation, it is given that force acting between the charges A and B is capital F. It is given in the that when the charges were separated by distance d, then the force acting between A and B is F. It is given in the question. Okay. What happens next? The question says that if 25% charge of A is transferred to B. Now what it says is 25% of this charge is transferred to B. Correct? Yes, its charge is reduced by 25. It means now this charge becomes, if I say QA, what is QA now becomes Q minus 25% of Q. Q minus 25% Q. It reduced by 25% value. What would be the value of QA now? QA will be Q minus 25% means 25 by 100 into, it was capital Q initially, so let it get capital Q. So Q minus 25 by 100 into Q. So this value will come as Q minus Q upon 4. So that will be 3Q. So the charge of A will become 3Q by 4. Similarly, what will be charge of B? It will gain 25% charge of A. So its charge, what will be the value of QB? QB will become minus Q was its initial charge plus it gains Q by 4 charge, right? So it will become minus 3Q by 4. Got it or no? Till now, anyone having any doubt? Everyone understood this thing? Q and QB?
Yes, sir.
Yes.
Okay. So now we can find the force. Now we can find the new force, that is, we can say F dash. F dash will be A Q A Q B divided by D square. Distance D will be the same. So I will keep it K by D square separate, and I will put the value of Q and QB. QA is 3Q by 4 and QB is minus 3Q by 4. So I will put magnitude only. There is no need to give this sign because we only have so 3Q by 4. So it will become as K by D square into 9. 9Q square by 60. So, and this force F dash we can say dash is 9 by 16 into AQ square. AQ square should be square, right? So the value of F was, in the question, the value of F was, if AB was given as F, and what was the value of FAB? Initially, what was the value of F? It was equal to K. What was the value of F? It was equal to K Q square by D square, right? K Q square by D square, because in the force between A and B was K Q1 Q2 by D square. So the value over by D square is F. It is given in the question. So the new force become 9 by 60. Have all of you understood this question? Any issue? Please tell me. Anyone having any issue? You can ask.
No,
Okay. All of you can see the screen. No?
Yes, sir.
Okay. So this is how this was 2019 question, and it is based on Coulomb law. Let's move to the next question, which is also based on Coulomb law. I will also, after the class, I will also give you some assignments, which will be based on Coulomb law only. So let us move to the next question. To write the question. Mm, this question has been asked in 19. Let us write point charges. All of you write next question. Point charges plus 4q. Point charges plus 4q plus 4q, comma, minus q. Point charges plus 4q, comma, minus q, and plus 4. Point charges plus 4q, comma, minus q, and plus 4q are kept on the x-axis. Are kept on the x-axis at points x equal to 0, x equal to a, and x equal to 2a, respectively. X equal to 0, x equal to a, and x equal to 2a respectively. So these charges are kept at x equal to 0, this is kept at x equal to a, and this is kept at x equal to 2. Full stop. Then option A. Option A says only, option A says only minus q is, only minus q is, only minus q is in stable equilibrium. Only minus q is in stable equilibrium. Equilibrium. Stable equilibrium. Option B says, option B says option B says none of the charges, option B says none of the charges is in equilibrium. Option B says none of the charges is in equilibrium. Option B says none of the charges is in equilibrium. Option C says all the charges are in unstable equilibrium. Option C says all the charges are in unstable equilibrium. And option D says all the charges are in stable equilibrium. Right, option D, it says all the charges are in stable equilibrium. So
What's
have
option
you
C?
read here? Fourth option says all the charges, all
Option
the
C.
charges. Option C says all the charges are in unstable equilibrium. All the charges are in unstable. Unstable. So basically you have to find the charges are in stable or unstable. Everyone understands equilibrium. What is equilibrium? Are everyone aware of that? The condition, equilibrium condition. Equilibrium condition means you can say in remaining that position only. Means whatever their position, they remain in that. Or we can say if total force is zero, then we say that any system is in equilibrium. If total force acting on a charge or any object is zero, then it is said to be equilibrium. It means whatever is the state of an object, if it remains in that state, that that is said to be equilibrium. In note you can write. You write in note here. You write in note here. Any object, any object, any object is said to be in equilibrium. Any object is said to be in equilibrium if total force, if total force or resultant force, if total force or resultant force acting on the object, if total force or the resultant force acting on the object is zero. Total force or the resultant force acting on the object is zero. Full stop. It means whatever, it means whatever be, it means whatever be the initial, it means whatever be the initial situation of the object, it means whatever be the initial situation of the object, it will in that situation, it will remain in that situation. It means, it means initially if the object is at rest, it means initially if the object is at rest, it will remain at rest. It means initially if the object is at rest, it will remain at rest, or if it is in uniform motion, or if it is in uniform motion, it will remain in uniform. So the main concept is total force should be zero. To satisfy equilibrium condition, total force should be zero. Now you check this question. What it says, it has given different charges, and we have to check that the total force is zero or not. So solve it. So Mamona says option C, all are in unstable. Can you explain why it is in unstable equilibrium? Mamona,
Yes, sir.
can you explain why it is in unstable equilibrium? All are in unstable equilibrium.
Because the charges are returning back. So they all are not in equilibrium or stable equilibrium. So that's why I chose option number C.
Okay. Anyone else? So I don't have much time right now, so I will solve this question right away. So let us see. The question says that point charges plus four. This question was a NEET question, right? NEET 2000. This question is NEET 9. It's old question 1988. Who has lost in NEET 1980. So let us see. Point charges. The question says that the point, let us assume this is an x-axis, and the point charges plus 4q minus the point charge plus 4q is placed at this point. First I will write the points x is equal to 0, x equal to a, and x equal to 2. So these are points given in the question, and the charges placed are like at this point charge is plus 4q, and at A the charge is minus q, and at 2A the charge placed is plus 4q. Right. The charges are placed like this. This one is plus 4. Now question says that point charge is plus 4q minus q, and plus 4q are kept on the x-axis. X is equal to 0, x equal to a, and x equal to 2 respectively. Then first option says only minus q is in stable equilibrium. only minus q. So let us check this option. The question says option A says only minus q is the stable equilibrium. So stable equilibrium means, what is a stable equilibrium? Stable equilibrium means this charge will always be in stable equilibrium. It means if I disturb its position, suppose I push this charge here. Suppose I push this charge minus q to this point P. It should always remain at point P. Understood or not? So stable equilibrium means if I push a charge, I disturb a charge from the given point, it should always return to that point. Correct or not?
Yes, sir.
So what will happen if I put this charge minus q to point P? This will insert a force on minus q, and this will also put a force minus q on it. Got it or not? So what will happen? It will try to get the resultant force will be downward, because on this charge, suppose in this direction force F1 is acts, and its direction force F2 will act. So both the force will try to push it back here. But what will happen? This charge plus 4q and this charge plus 4q will also be exerted by this force. This charge minus q towards the center. If I see this charge 4q, this also be exerted by the charge minus q towards A, because a force will also act on plus 4q and a force will also act on the right charge plus 4q. So everyone is acted by unbalanced force. Here if you see, every charge is acted by an unbalanced force. No one is getting balanced force. Right or wrong? Getting my point? If you see, the charge plus 4q is acted by a force towards minus q, and if you see this charge plus 4q is acted by this charge minus q from the central charge, and the right charge plus 4q is also acted by charge minus q. So both are acted by unbalanced force. So we cannot say that if we see the option D, all the charges are in stable equilibrium. This cannot be correct, because if we see the charge at x equal to 0, it is acted by unbalanced force. And if we see the charge at x equal to 2a, it is also acted by unbalanced force. So option D cannot be correct. Okay, so I will now time is going to over. So what I will suggest that the remaining options I will explain you in the next video. So all of you, what you do, I will give you this question, all of you in assignment also. So all of you try yourself also, and we will discuss in more detail in the next class also. Okay, because the time is running up, so you all are will be in hurry, so you all may not be able to understand it clearly. So I will give you this question in the assignment also. I have explained you the option D, remaining three option. I will explain you in the next class. All right. So you all can try it, and I will explain you in detail, because it requires every option to be explained clearly. Okay. So any
Okay, sir.
doubt till now? You try. I will give you this question in the assignment. You
Yes,
try,
sir.
all of you try at once.
No,
Then I
sir.
will explain you in detail. Okay. Anyone
Okay, sir.
having any doubt about? Okay. So I am signing off for today. Try your
Okay, sir.
get study and revise